So wind in general, right? It's the movement of air. That is wind. But it's caused primarily by differences in pressure. Now, what we're going to talk about over the next 2 weeks is that there's a lot of different ways to cause differences in pressure. But that's like the main piece of it. High and low pressure areas cause air to move. If we have an area with very few air molecules and another spot where we have a lot of air molecules, that's our high pressures when those particles are closer together, the wind is going to move from high to low because it's going to try to balance it out. So a lot of air molecules, when they're stuck closer together, we have a higher density of air, aka higher pressure. It's going to push it towards that low pressure area. And that's what wind is. Differences in pressure trying to equalize out. So how are local winds actually created, right? How do we get these areas of high and low pressure? Well, pressure differences are the main cause of wind. We just covered that on our last slide. But how do we get them? So one big piece is temperature changes. Hot air rises, that's a lower density area, which means it creates lower pressure. So in this region on our picture, the sun is out, it's heating up our land, right? The warm air over the land starts to rise, creating a low pressure area. So we've got really hot land, we're going to get a rising of air because it's hot just like lava, and that creates low pressure. Now, on the other hand, there's areas on our planet that aren't getting quite as much sunlight. So they're actually going to be cooler areas. And cooler particles, remember, those particles, they slow down and move closer to each other. So the cold air is more dense. And because it's more dense, it sinks down to the planet, creating a high pressure area. And so these temperature differences actually cause our pressure differences. Hot air rises, cold air sinks, and all of a sudden we have this high to low pressure center. And winds are going to blow from high to low pressure. These cooler areas to lower areas, that's where we get our wind. So yeah, local winds are caused by pressure differences, which are typically caused by temperature differences. Now, the reason we're learning about this, right? Weather affects us all the time. And by knowing what kind of pressure system you're near, you can actually predict the weather. Not just what kind of wind you're going to get, but actually if it's going to be a beautiful day out or if it's going to be kind of crummy and rainy. So what kind of weather do we get at each type of pressure system? Well, here's how it's done. Warm air can hold more moisture. So warm air particles, they're moving faster. It just allows for more moisture to be soaked up into our atmosphere, which is pretty cool, pretty cool. The troposphere gets colder the higher you go up. Now remember, the troposphere is that bottom layer of the atmosphere. It's a layer of the atmosphere that we live in. So here's what happens, right? Warm air creates low pressure because warm air rises. What do warm things do? They rise because they're less dense. So that warm air, which is super moist, can hold a lot of moisture. As it rises, it cools down and it can't hold on to that much moisture. So we got hot air in this picture over here. Starts to rise. As it hits the colder part of our atmosphere, the atmosphere can't hold that much moisture anymore. And that causes clouds to form. So these low pressure areas, even though it's warmer air at the surface, as it rises, if it rises fast enough, it creates very unstable air that's going to form massive clouds, and that's where we get our storms. So low pressure systems are actually where we see rain, storms, thunder, hail, all sorts of things happen at these low pressure systems. So even though it's our hot air that's rising, right, it sounds pretty neat, that's actually where we get our most inclement weather or our harshest weather. The faster this air rises, the more dangerous the weather is because it just makes for a really unstable atmosphere. So low pressure systems, we got hot air rising. As it rises, it cools, causing clouds and storms. Now, on the opposite side of things, our high pressure systems are the exact opposite. So high pressure systems start up high in our atmosphere. And up in our atmosphere, the troposphere, right, we don't have a lot of pressure. So because there's no pressure to hold in the heat, it's actually pretty darn cold up here. So because that upper atmosphere is cold, it's also really dry. It can't hold on to that much moisture. So this really cold, dry air, remember cold things actually, those particles can't move fast, so they move closer and closer together, causing it to be more dense. So this really cold, dry air in a high pressure system sinks down to the ground. And that's what creates high pressure. It's air pushing down on the ground. That's the high pressure. And because we have cool, dry air drying out even more as it descends, we get sunny skies. Yeah, this is where we get our really nice weather in the sense that we don't have clouds. It's pretty dry out. We don't have to worry about humidity. And that's what our high pressure system is. So when we have these high and low pressure systems, they kind of balance each other out. Air moves from these high pressure, sunny systems towards those low pressure systems because those low pressure systems have hot rising air. Yeah, pressure, am I right? So that's what it looks like on the grand scale. That's like the basics, right? We got high pressure, we got low pressure. Now a sea breeze is where we're going to look at a specific instance. So I was just in Duluth this past weekend, and I had the luxury of experiencing a sea breeze and a land breeze. There's a reason that happens. So a sea breeze happens during the day, so we can see the sun's out. Now, if you remember from our labs, oh gosh, week and a half ago now, we had a station where we had a cup of water and where we had a cup of sand. And we tried to see which one would heat up faster. And our data showed that land heats up way faster. And that's because water is a high, what we call heat capacity. It just doesn't like to change temperature. Biggest thing you need to know, land heats up quickly. So when the sun comes out, the land starts getting pretty darn warm compared to the water. And what do hot things do? Hot things rise. And this is what creates our low pressure system. So typically what happens on coastal areas is in the afternoon, you tend to get thunderstorms. And that's because as the land heats up more and more throughout the day, that hot air rises up, causing clouds and precipitation. So usually in the afternoon, that's when you see storms start to roll in, maybe some rain clouds, especially if you're in a coastal area. Not necessarily in the middle of land, but if you're near a large body of water, you see that hot air rising in the afternoon, boom, you get clouds, maybe even some precipitation. Now, as that's happening, the water is staying cooler, not cold, like it's not cooling down, but it's relatively colder than the land. And that means the air over here is more dense. It doesn't have as much energy. So it sinks down on top of the water. And all of a sudden, if you look at this, we've got a high pressure area, we've got a low pressure area. And wind always goes from high to low every time. So this is a sea breeze, happens during the day. Land heats up faster, hot things rise, creating low pressure. Cool air sinks, and we go from high to low. It's called a sea breeze because the wind is coming from the sea. Now this happens during the day, but keep in mind, our land and water still heat differently, right? Water doesn't like to change temperature. Land has no problem changing temperature. So at night, right, where'd the sun go? There's no sun, which means land is now gonna cool down rapidly. It's gonna get way colder, way faster than the water is. And this ends up kind of reversing what's going on. So on Saturday night when I was in Duluth and I was just standing on the shore, right, it was great. All of a sudden, instead of feeling the wind in my face, I felt the wind at my back. And that's because the land cooled down so much faster that the air started to descend. It created a high pressure center because it was cold. And the water didn't change temperature. So the water was actually warmer than the land. This is also why if you ever go swimming at night, it tends to feel warmer in the water because the air cools down so rapidly. So if you ever do nighttime swimming, you get permission from your parents, but that's why it tends to feel warmer. So we had cool land, we have warm water air. So the air over the water is rising because that's the hot air, and we go from high to low. And that's our land breeze because it's coming from the land. Yeah, we name breezes based on where they're coming from. So those are our two main breezes. We've got a sea breeze, comes from the sea. We've got a land breeze, which comes from the land. And it all has to do with whether the land is hot or cold. During the day, it heats up, creating a low pressure center. So we get wind from the sea. During the night, it cools down pretty darn quickly, creating a high pressure center. So we get wind from the land. And that's a sea and land breeze. So what you can do for the next part of class is to go to the CK12 local winds. That's in today's folder. You're going to open it up and you're going to read through what causes local winds and complete your notes based on the reading. So go ahead and open that up. Take a look at those different sections. When you're done, complete the practice for points. It's out of 10 points to review the information that you've been learning. And I hope you enjoy, everybody. Wins are great. Winning. Yeah. Have a good one.